Hey folks, welcome back to 271 Cognitive Psychology. This week we're looking at problem solving. And this week we're going to see a lot of material that we've covered already. For example, memory, schema, heuristics, that sort of thing, mental models, and mental shortcuts, and so on. We're going to see that applied to the psychological phenomenon of solving problems. This little comic book strip here shows us that some problems really aren't that difficult to solve and aren't really worthy of the title problem, but there are plenty of other problems that we can see that do require some sort of solution. For example, just have a go at this in your own time. It might only take you 30 seconds. Just have a quick attempt at it before we move on. What word can be combined with each of the three words, right? So the very first one, I'll give you the answer to this one, and the answer is ice. Hopefully my mouse is in the right spot this time. Ice cream, ice skate, ice water, right? So try to complete all of the other ones, and just as you're doing it, think about the different strategies that you use. You might have a particular a mental model or an approach that you rely on. For example, in this one, ice comes before all three words. Ice cream, ice skate, ice water, right? So one approach to solving this problem that you might engage in even subconsciously is to think, okay, what word can go in front of each of these words, right? Then you come across a different example over here, this the top right one, rocking, chair, wheelchair, high chair, right? Okay, now it's slightly different. Now you've got to see, maybe there's a word that you add to the end of each of these words to form the conjunction, right? So now you've got, okay, let's add words at the front, and then you've got, let's add words at the end, and you come across various different strategies which through trial and error you realize, oh, this strategy might work, that strategy might work, and through this exercise you'll start to see, oh, okay, my mind is actually automatically engaging in various methods of problem solving even without me realizing. So have a go at this activity, see what strategies you automatically come up with. Here's another exercise that we can use to investigate the phenomenon of problem solving, because problem solving requires creativity, right? So we often think of creativity as it relates to the arts, right? Musicians and painters and sculptors and designers and architects. Well, these people are creative, right? Well, obviously they are very creative, but I want to disabuse you of this stereotype that that is where creativity lies. I would say Bill Gates is extremely creative. I would say that politicians that come up with novel strategies to tackle certain problems, right? How are we dealing with coronavirus right now? Well, that requires a lot of creativity, right? So creativity can manifest, and problem solving can manifest in all walks of life. Now, how do researchers actually go about measuring and investigating creativity and problem solving? If I were to give you a political problem to solve, well, some people are naturally more wired to think and process in terms of politics. If I were to give you, an artistic creativity exercise, obviously some people are going to do better than that at others. So we need ways to measure creativity and problem solving that kind of cut across all different individuals, different professions, and so on, so that we can get a good general measure of it. So this is one example of such measures, and I believe we've looked at this before briefly. So try to come up with as many uses as possible for a brick. Just press pause, spend a minute trying to come up with all possible usages. And also I want to add here that in our traditional face-to-face lecture format for this course, we would have allowed a lot of time in class for you to actually try to solve these problems. So on the one hand, that's why this lecture will be a little bit shorter than normal, but on the other hand, try to press pause throughout this lecture and actually solve these problems as we would be doing in class. So now I'll give you some examples that people come up with in response to this question, right? So some very common examples, which might not be all that creative, are you can use it to prop open a door, or you can use it as a paperweight, or obviously you get some jokes about using it for criminal activity and whatnot, right? But there are relatively creative answers to this. So for example, one that I heard is you can crush it up, turn it into a paste and use it as makeup. That's a very creative example because it's creative because it's going beyond the typical function of the brick. And so that provides some insight into how we conceptualize creativity in the world of psychology and how we actually go about studying it, right? If you can come up with an interesting and usable functional usage for this brick that goes well beyond its typical usage, well then that is treated by psychologists as an indication of creativity. And here we have another example. This is a classic example from the 40s. Participants are given candles, thumbtacks, and a matchbox with matches in it, and you have to mount the candle to the wall to avoid dripping. So, if you don't remember this one, pause, have a second to try to solve it, and I'll give you the answer now. Basically, you empty the matchbox. So that is one of the tricks that throws people off. You don't actually need the matchsticks for the structural integrity of the mounted candle. You need the matches, obviously, to light the candle, but you can empty the matchbox and then pin the empty matchbox to the wall and then place the candle in the empty matchbox so that it catches the dripping candle wax. So that's another example of using items beyond their typical function. And that's something that's going to come up a lot in this lecture. Can we go beyond the typical function that we perceive in relation to this item in our mental sets, our mental models of, our kind of mental stereotypes, if you want, of these objects and their typical function. So, this is the overview for our lecture today. We're going to define what we mean by problem. We're going to look at the Gestalt approach to problem solving, and we'll do a quick revision of what Gestalt is, because we've covered this here and there. We'll look at creativity versus insight in problem solving. And then finally, we'll look at analogical reasoning. So establishing analogies, metaphors, trying to come up with similar examples to the problem that we're trying to solve now, and seeing if, thinking about different problems can help us solve the problem at hand. Okay, so what is a problem? This is a good example in psychological science of how we really need to define our terms, right? Because for most of you, you probably never thought, well, what's the definition of a problem? It just seems obvious. A problem is something that causes you trouble and you want to try to get over it, right? But that adequate lay definition notwithstanding, when we study a concept in science, we need to be very specific in how we define that concept, and that is especially the case in psychology because these concepts that we study, right, problem solving, creativity, judgment, decision making, reasoning, and so on, they're such complex phenomena with so much, cross-cultural variance, and everybody differs in how they understand these things, that it's very important that we have a concrete, clear definition of the term before we investigate it. So the basic definition that cognitive psychologists rely on when studying problem solving is that problems entail two main features. First of all, I guess you can say three main features. You have a goal. That might be the first feature. You have a goal, and then the second feature is that there's an obstacle preventing you from getting to that goal. Now, that obstacle might be really big, right? Like, how do I get into law school? Or it might be really small, right? Like, how do I drive to my friend's place today? 10-minute drive, you just got to look it up on the map, right? So the obstacle might be big or it might be small. And then the final feature is that the solution to your problem, or the solution in terms of overcoming the obstacle, is not immediately obvious, right? So if you have a problem like I'm hungry and you're at home, as we all are right now, well, that problem is pretty easily solved. You just go to the fridge and get some food. We wouldn't really discuss that in terms of problem solving in the psychological literature. It's more where there is an obstacle to your goal and it's currently not particularly obvious how to overcome that goal. You might figure out the answer in 5 seconds or 10 seconds, so you needed 5 or 10 seconds to think, or you might need a year or 10 years to solve the problem, right? But the point is, in the immediate here and now, upon recognizing that there's an obstacle between you and the goal, either you immediately see the solution. In the hungry case, obviously the solution is go to the fridge and look for food. Or it might take you a while, be that 5 seconds, 10 seconds, an hour, a year, or whatever, to figure out how to overcome that obstacle. So those are the general features of a problem. Okay, so what is problem solving? Well, beyond the definitions that we've already given, talking about, an obstacle between your current state and the goal, well, you obviously have to identify ways to reach that goal, means or ways or methods to attain that goal, to overcome the obstacles, to get from your present state to a goal state, right? And, given everything else we've discussed when it comes to cognitive psychology, you will hold on to information from your trial and error efforts, right? Your attempts to overcome a particular obstacle. Does it work? Does it not work? Well, you're going to recall a lot of this information, and in the future, either consciously or unconsciously, you're going to draw from your experience of problem solving. And now you might be able to take, problem-solving attempts you've applied in one domain of your life. So, for example, well, I was a C student, and then I wanted to become an A student, and I followed a particular means of solving this problem, and eventually I became an A student. Awesome. Now I have a different problem. Now I'm trying to find a home and, secure a job and, whatever, and fix up my CV. You might be able to find some common strategies that you use to solve the first set of problems that you can then apply to this second set of problems. Maybe or maybe not, but the point is, from our perspective as psychologists, we're interested in how the mind organizes that information and then draws upon that information for future problem-solving activities, even if it's a different type of problem. So, yeah, as I was just saying, memory, perception, knowledge, patterns of learning, heuristics, mental shortcuts, all of these come into play. So just a couple of really, really simple illustrations of problem solving, right? Oh, I'm really tired. I've got a lot of work to do, but I don't quite have the energy, right? So this is a little bit more complex than the I'm hungry problem that I mentioned earlier, because there are various different ways somebody could address this problem. Maybe she could sleep it off, right? Or in her case, maybe she go for a run, get her energy levels up, or in her case, she decided to have a coffee, right? So there are many different solutions to this problem, and the solution in her immediate situation upon asking the question, how do I get more energy? There wasn't one immediate solution. There were a few different options, and you kind of had to weigh them up, which was the most feasible, and so on. So there was problem-solving activity involved. Another example, well, if you're Nicolas Cage and you want to steal the Declaration of Independence, well, there are going to be a lot of obstacles in your way. This problem is a much harder problem to solve, obviously. But still, fundamentally, the reason why I present such starkly different examples is to show you that beneath the surface, psychologically speaking, there are many similar properties to these examples in terms of recognizing an obstacle and trying to overcome that obstacle, weighing up different options, and so on and so forth. We have different types of problems, of course. So one of my favorite movies, Good Will Hunting, he has to solve math problems. Turns out to be a genius. We can, choosing a major in college, you've got different options available, and you ultimately need to choose a major, but you don't know which major is going to be the best, and so on. So you have this problem of there's a deadline, I have to choose a major by this time, but I don't want to choose the wrong major, and I want to choose a major that'll give me a good salary in the future, and so on and so forth, right? So you've actually got a number of problems in there. The problem of choosing a major by the deadline, the problem of choosing a major, the problem of making sure I get a decent salary in my future, or the problem of making sure I find a job that I enjoy, right? All these different problems bundled into one. If you're a Harry Potter fan, maybe one problem is trying to levitate a feather in Hogwarts, and the solution to this problem is the pronunciation of the incantation that you're trying to recite. In this case, Leviosa, not Leviosa, right? Another problem on a much grander scale is how do we achieve world peace? Now, this problem is particularly plagued by definitional issues. What do we even mean by world peace? Is it even imaginable to have, not even a single instance of conflict in this great big world of 8 billion people, right? It might be a problem that's completely intractable and unsolvable, but we can still understand it in terms of, a problem that encourages and promotes psychological processes of memory, analogical thinking, and so on. How do we investigate problem solving? Well, I touched on this a little bit in terms of, how we measure creativity and so on. So with that example I provided you regarding the brick, and how do we, how might we reuse a brick in various different ways? Or how do we mount the candle to the wall and so on, right? So one of the advantages of these methods of measuring problem solving is that they're pretty neutral. They're neutral in terms of, positive versus negative, good versus bad, like versus dislike. Like, who likes or dislikes bricks, right? Who has positive or negative feelings towards bricks? Doesn't really make sense. Or candles and matchsticks and so on, right? So they're pretty neutral, and they're not examples that you're going to see excessively in one domain of life versus another, right? I mean, even if you are, a brickies laborer, or you work on a construction site, even more so, you're going to think of bricks in terms of their traditional function, right? Your exposure to bricks in those environments isn't going to make you this amazing problem solver. So these are pretty neutral methods of studying problem solving. So they work quite well. Let's look at another example. This is called the Tower of Hanoi. This is very common if you look at textbooks of cognitive psychology and so on. So you might have seen this before. Basically, you have an initial state and you have a goal state. So that's perfectly capturing the definition of problems and problem solving that we addressed earlier. So you have 3 rings on that first rung or rod or whatever, and they're different in size, and there are rules. You can only move 1 ring at a time, and you can't move a ring if it's below another ring. Oh, my apologies, there's one other rule. You can't put a big ring on top of a small ring, right? So you would have to move this small ring first, and then you would move the middle ring to a different rod, because the middle ring can't go on top of the smaller ring, and so on. So play around with this. See if you give it a try. You'll see that you'll use a lot of trial and error. You'll use visualization, and with trial and error, you'll be learning things. Your short-term or your working memory are going to be activated a lot, holding on to information in your current working memory to try to learn from trial and error and solve the problem. So give that a go. You'll find it's mainly a case of trial and error. Okay, so that is how that's one of the ways we measure problem solving. Now let's look at it from a slightly more theoretical perspective. What is problem solving? Why is it tricky? Why do we encounter challenges with problem solving? What are some of the limitations that we often find when it comes to problem solving? And how do we overcome them? So, a quick little refresher here. What is Gestalt. Just take 15 seconds, just press pause for 15 seconds, no more. Just stop and think to yourself, what is Gestalt? What do I remember from Gestalt? What if I had to explain Gestalt to somebody in 5 seconds, what would I say? Just stop 15 seconds, think about that. Okay, so Gestalt comes from, is a German word. It basically means form or whole, right? We are looking at the entirety of an image or a phenomenon or a concept or whatever, right? So for example, in the past, I've given you an example of an office, and participants are asked later how many books were in that office. It turns out there weren't any books, but most participants remembered there being 10 books or 15 books or whatever. Well, that's because they're relying on a Gestalt impression of offices, a stereotype or a schema or a mental model of what offices look like. And in their Gestalt, focusing on, offices as in this holistic sense, in their Gestalt of offices, there are books. Some other examples coming up shortly, right? So we organize our sensations to perceive a meaningful whole, and we're actually kind of hardwired to see meaningful wholes rather than look at details. So one of the best examples I like to give here is that you see triangles and a star. You don't see little Pac-Man figures and incomplete acute angles. You actually see, your mind kind of completes the image for you. You see a holistic triangle or a star, right? Even though there actually aren't any triangles or stars here. Another example, when we see faces, right? We process the face in our minds holistically. We don't break it up into smaller parts. And in fact, we are hardwired to be really good at recognizing and remembering and imagining faces rather than the details. So for example, think about family members, loved ones, spouses, boyfriends, girlfriends, best friends, whatever. Think about even your own face. Try to imagine, where is the mole? Or where is that little blemish? Or what color are her eyes? And, does she have a gap in her teeth or whatever? You're probably not going to be able to answer these questions very well. Because you don't think about these details. You just think about a face as, that's Anna's face, that's Heather's face, that's Hector's face, that's Julio's face, whatever, right? You think about it holistically. So facial recognition is a good example of holistic Gestalt processing. And in fact, we actually have neurons in the brain that are specifically dedicated to processing very specific faces. So research going back to the 90s, for example, demonstrated that, using 90s cultural references, people had certain neurons in the brain that fired just when they saw Bill Clinton's face. And when they saw somebody else's face who was, posing in the same way, but it was a different face, the neuron didn't fire. They also had neurons for, just for Jennifer Aniston's face, and it would only fire for her face and nobody else's face. So it's pretty amazing when you think about it, how many literally like millions or billions of neurons we might have for specific individual people, because our brains are so hardwired to recognize and process specific faces rather than generalizable qualities of faces and the details therein. So anyway, that's some Gestalt for you. Some more examples, right? We tend to organize stimuli into coherent, cohesive kind of the information cooperates to form a holistic impression, you might say. So for example, lines that are together are probably groups. Or things that approximate are probably grouped, right? We can organize information based on their location relative to each other. Or if things are similar, then that's probably a group, right? I'm much more likely to group columns than rows in this example. Why would I group rows when each row contains different information, but each column contains the one piece of information? That's how our minds work. Your mind automatically groups this in terms of columns and not rows. Another example, continuity. Well, the word continuity turned out to not be very continuous in this example, but as you can see, there are two lines here, right? We all recognize that there are two lines. Now, what are those two lines? Well, your mind, without even thinking consciously, has subconsciously already processed this to recognize that there's one straight line and one, you can call it like a sinusoidal line, right? It's following like the sine SINE, if you guys remember high school math, right? So those are the lines that we see. We don't see the other possible pairs of lines. If you play this image out in your mind and manipulate it, right, you could see that there could be other lines. There could be, for example, straight line, mountain, straight line, mountain, straight line, mountain, and so on, right? Or there could be straight line, ditch, straight line, valley, or whatever you want to call it, right? So we don't see them. We see the straight line and we see the squiggly line. Connectedness, things that are connected usually go together. Closure, we looked at that already with the triangle and the star in the previous image, right? So long story short, we form meaningful, holistic impressions of the detailed stimuli that reach our sensory processing. Another example, right, we're good at depth perception, we're good at recognizing 3 dimensions, even in two-dimensional representations, right? So we see this and we don't think, oh, those 2 lines are eventually going to join. No, we recognize that this is 3-dimensional, and that the lines are parallel. And you don't need to exert any mental effort to do this. It just happens, right? So yet more examples of how Gestalt is an automatic process of the mind. We recognize patterns and we apply pattern recognition to our interpretation of novel information reaching our senses. So, according to Gestalt, these are learned or pre-existing structures of knowledge or mental models, heuristics of interpreting information. They facilitate how we process new information, right? So if you see 2 lines drawn on a piece of paper and they're kind of approaching each other, much like this image, well, you're going to apply, subconsciously, you don't even need to consciously do it, you're going to apply your mental model of depth perception in 3 dimensions and parallel lines and make the inference that, oh, okay, these 2 lines aren't connecting at the end, they're parallel lines, and I'm looking at a 2-dimensional representation of 3 dimensions. Quite a complex, jumble of thoughts and words just there, but your brain does that in less than a split second. All right, now how does this help us understand problem solving? Let's take a look. So, the Gestalt approach understands problem solving with reference to the notion of mental representation, right? So think about Gestalt in the sense that we have a mental representation of a holistic form, even if we can't actually see that holistic form in our vision, right? So the triangle and the star I showed you earlier, we have a mental representation of what the shape is kind of supposed to look like. We rely on prior learning and preconceived notions about how to solve a problem. So this is how we apply it to problem solving. Now these preconceptions are called mental sets. Mental sets are like schemas or heuristics. This is a set of mental imagery, visualizations, and assumptions, and so on. Now, some students ask, what is the difference ultimately between schemas and heuristics and mental sets and so on? I'm not too concerned with the differences here. I think these differences, they get extremely complicated, and therefore a more advanced discussion. For our purposes, it suffices to understand these things as kind of all being kind of similar to one another. And a mental set is the term we use for problem solving and mental imagery, rather than we're using the term schema and heuristics and that sort of thing. But don't worry too much about this terminology. So mental sets can be very helpful. So for example, solve these riddles, and I'll just press pause and give yourself a chance to solve them, because I'm going to go straight on to revealing them. Okay, so what do you think the answer is? The answer is forgive and forget, because there are 4 gives and there are 4 gets. Now, let me give you an example of mental sets. How you've now established a type of heuristic, or in this case, because we're talking about problem solving, a mental set of how to solve a particular problem. Let's see if you can now solve this next problem faster than how long it took you to solve this first problem. You ready? Here we go. The answer is too little, too late, right? And you got that I assume, much more quickly than you got the first one, because you had learned a mental set of problems, like, you know, a mental model of what problems look like and how to solve them, and you were able to apply prior information. So this is what we would call top-down processing, right? So you've established knowledge that can be used to make inferences about novel information, in this case this riddle, this novel information, and you are applying something already learned and established to process that novel information. Another example of how mental sets can be helpful, they can help us find patterns in novel stimuli, right? So if we have mental sets that you're used to solve problems, well, these are established patterns, heuristics, schema, you know, summaries of information and so on that we have stored in our mind that we can use to then apply to a new problem. However, there are some factors that come into play here, right? We have, are these skills well honed? Do we, you know, like, have you been playing chess for 1 year or for 10 years? How well honed are these skills? Right, and so compare extreme examples. Chess experts might look at the board and say, oh, that's a good layout for black. Newbies would look at the board and say, I see black pieces and white pieces, right? So obviously, applying mental sets, there's going to be varying sophistication of those mental sets and varying ability to actually apply them to problems at hand. So yeah, you have to actually be able to apply them to the problem at hand. If you are relying on a mental set that you establish from playing years of checkers, for example, and then you come across this chessboard, well, the mental sets that you establish for solving problems in that game just aren't really going to apply all that much here. Maybe there's a little bit of crossover, but generally speaking, the crossover isn't going to be that great, right? Let's consider another example. Let's say you're you know, you've been doing Taekwondo for 10 years or something like that, and then you join a mixed martial arts group where you have to come across people who use different forms of martial arts. Well, you will absolutely be able to apply certain problem-solving strategies and mental sets from Taekwondo to your new mixed martial arts activities, but you are obviously going to encounter some limitations for the applicability of those Taekwondo mental sets, right? Because you're going to come across some new problems, right? Now, you're absolutely going to be able to use your Taekwondo problem solving to try to solve these new problems, but of course, there's going to be some mismatch here and there. You're going to have to learn new problem solving strategies. Another example, something that I've given you before, right? We can compare a random chessboard position to an actual chessboard position, right? So the one at the top, well, let's look at the one at the bottom first. It seems pretty clear that this is a pretty typical layout for at the bottom. You've got the whites with the two castles, and the king is down the bottom. At the top, you've got the blacks' two castles, and the king is at the top, right? Whereas over here, you've got the white king and the black king up at the same section layer of the board, and you've got the two queens down next to each other. It doesn't look like a typical layout to me. So you've got an actual board position that you might expect to see and a random board position that you wouldn't expect to see. Now, because of you know, the mental sets used for problem solving that chess experts develop, well, it only makes sense that they do a really good job. There's a dependent variable here, right? Percentage recalled. How much of the board do they actually remember subsequently when they were tested on it? Well, you can see that the novice it doesn't matter if it was a real game or a fake game. It's all new to the novice. It's all unfamiliar. There are no established mental sets, period, right? Whereas the expert, when they see this fake game, which they have no familiarity or experience with at all, their memory isn't so good. It's really actually no better than the novice. But then when we see a real game, all of their mental sets kick into gear, and those mental sets actually apply to the problem at hand. They actually apply to the layout on the board. So there has to be an establishment of mental sets, prior learning and so on, recognition, and there has to be a connection between those mental sets and your learning and the actual task at hand. Here's another example for you. Some of you will get this better than others. Which two of these go together? So one of these is the odd one out. So a novice, somebody who doesn't have any experience with dogs and cats, would say that these two go together, but an expert would say that these two go together because these two are dogs and the other one is a cat, right? So your expertise is going to vary in its complexity, it's going to vary in its applicability to the stimulus at hand, and also the stimulus itself, the problem itself, is going to vary in difficulty. And there are going to be some things that trigger our biases, right? So a novice is looking at this and thinking, well, these two are both white and small, have beady little black eyes and so on. They both look really similar, right? Evidence suggests that these two go together when in fact that is incorrect. So the nature of the problem itself is obviously going to be important. How difficult is the actual problem, right? So if we replaced this little white dog with a little brown dog that otherwise looks similar, well, then this problem would probably be a little bit easier to solve even for the novice. Now, importantly, we can often be too dependent on our mental sets and on our, heuristic automatic assumptions. Our autopilot can often be wrong, right? Our autopilot is extremely valuable, and, applying in this top-down manner things that we've learned from the past is extremely useful. Our brains wouldn't do it if it wasn't useful. These evolved for a reason. They helped our ancestors survive. But of course, we encounter many, many different problems in our day-to-day lives, and we're not always going to be able to apply one solution, one mental set, one problem-solving strategy to various problems out there, right? We can be too dependent on our fixed assumptions and habits and, autopilot approach to solving problems. We get fixated, that's a very important term here, we get fixated on one way of thinking about a problem. And so the solution is we have to restructure the problem in our mind, okay? So this is the Gestalt approach to problem solving, is to change the Gestalt impression that you have in your mind. Change the way that your mind processes that information and stores knowledge of that information, right? So change the way that your mind stores knowledge about faces or about, the triangle and star image or whatever. Like, restructure the representation in your mind of the actual problem so you can get out of thinking about the problem in its apparent qualities and try to get to a deeper level of understanding. So we'll look at some examples. As I was saying, in Gestalt, we are visually representing a problem in our mind, and then we restructure that mental model, that mental representation, right? So here's an example. If the length of the circle's radius is r, what is the length of line x? And so here's another example where if we were in class, I would pause and give you a couple of minutes to try to solve this. So see how you go. Try to solve this in your own time. I'm going to proceed with the explanation right now. Okay, so what we can do is we can just simply restructure how this image is represented in our mind by actually, we can draw on it if we had this on a piece of paper in front of us. We could play around with it, we could rotate it, you have to do all of this in your mind, which is a little bit trickier, of course. But you can, you recognize, okay, this is a triangle, and this triangle actually forms half of a rectangle. And if I complete the rectangle, well, then it looks like this. And, given the basic laws of geometry, right? I can infer that angle, the angle in that top left corner is the same as the angle in this bottom right corner, and so on and so forth. Therefore, x is the same as r, and R is the radius. Right. So obviously it requires a decent amount of knowledge of geometry and so on, but the point is, all you had to do was slightly restructure this image in your mind or on the paper in front of you, recognize that this triangle doesn't have to just be a triangle. We can also represent it as being, you know, half of a rectangle, and then from there you get all sorts of different solutions coming to mind because you have changed the way that the image is represented in your mind. It's no longer just a triangle, it's now a triangle, half of a rectangle. Oh, and hey, now thinking about a rectangle, all sorts of different inferences based on geometry emerge. Here's another example. Pause, read this, and give yourself a couple of minutes just to think about how you would solve this problem. Draw it out, you know, use imagination, try to use a pen and paper, come up with various different ways to present and represent this problem. Okay, I'm going to proceed with the solution now. So the solution turns out to be really quite simple, and all we have to do is recognize that ultimately what we're talking about is a pretty simple XY graph. We have time of the day and we have location. Those are our two variables, time of the day and location on the mountain, top of the mountain versus bottom of the mountain, right? So we can chart that this is the monk's path. Doesn't matter, even if it's like not quite like this, there's obviously going to be a beginning and there's going to be an end, and the end is going to be at the top of the mountain, the beginning is going to be at the bottom of the mountain, right? So all we have to do is recognize that on the very next day, going from top to bottom, the exact same process occurs, and these two lines are going to have to intersect at some point, right? And if the two lines intersect, well, that means that there is the same time of the day and the same location on the mountain. If we go over to this point, and hopefully my mouse is in the right spot, we see that they do intersect at some point. They have to intersect. It's a given, right? And we had to restructure the problem to see it. When you put it when you draw it out like this, you see so obviously, of course, they have to intersect. But it was very difficult to recognize that before we were tasked with re-representing the problem. So, in a nutshell, if you need to understand something better, if you're struggling to solve a problem, or if you feel like you're only seeing something from one perspective, then restructure your representation. Imagine it in different colors and shapes and whatever, right? Like, play around, draw it out in front of you, manipulate it using computer software if you can. Just do something to restructure your representation, right? And maybe this is one of the reasons why when we experience something using different sensory modalities, right? We see something versus hearing something versus feeling something. Maybe that's one of the reasons why it's really good to try to experience something using multiple sensory modalities, because it helps us represent the stimulus that we're processing, right? An image or something like that, with various modes of sensation and interpretation and representation. So you can draw pictures and charts and so on. You know, you hear about these mind flow maps or whatever they're called. These are really helpful for you to see, like see the forest for the trees. Say you're trying to write an essay where you draw out this big mind map and you see all the pieces connecting together, and you have a different representation of the problem at hand. Try to think outside of the box, think beyond your constraints, recognize that there are some constraints, and try to structure the problem so that those constraints are no longer a problem. And you know, thinking out loud, it's kind of similar to what I was just saying. Thinking out loud, well, now you're hearing the problem as well as just seeing and thinking about it. You're activating different sensory modalities. Okay, let's now go on to creativity and this concept of insight. So stop and think about what you take insight to mean, right? Something might have been insightful, or you know, maybe insight refers to, you know, instinct, being able to read people well, or having good, you know, intuitions or something like that. Anyway, there might be various ways that you interpret this term. Insight in problem solving can be discussed as following. Now, as we discussed, problem solving usually means we are slowly working towards a goal, right? It's slow insofar as it's not immediate. If the solution came to you immediately, well, then it's not really a problem, right? The definition of a problem, as we provided earlier, is that there is an obstacle between your current state and your desired goal state, right? However, that's not how we always solve problems, right? Think about your own experience. Sometimes we just suddenly perceive the solution to a problem, like a light bulb goes off in our head. There was nothing that led up to it clearly and directly. It's just suddenly we figured out the answer, right? So think about two different experiences that might help you as an analogy for understanding this distinction, right? Imagine, think about when you're trying to remember something. You're trying to remember the name of a song or the name of a person or the name of the movie you watched last night or whatever it might be, and it's on the tip of the tongue, you just can't quite remember, right? Think about two different experiences you have with that process. On the one hand, you might recall bits and pieces of information gradually, one at a time, and it gradually builds up and up and up and up until you finally remember the name of that person or the name of the film. I remember it had Tom Cruise in it or whatever, or had The Rock in it or something, and that gives you some clues, and that helps you rule out certain things and narrow down your choices, and then eventually you solve the problem, you remember what you're trying to recall. Another experience is you don't get any of that step-by-step experience and information building up and up. Instead, it just suddenly comes to you. You might be thinking for minutes or even hours. You're not getting anywhere at all, and then suddenly it occurs to you, oh, that's right. That's the name of the movie that I was watching, right? So these are two very different experiences of recall, right? One of them is step-by-step, and you're building information and evidence up and up. The other one is it just happens suddenly. So this latter one, this sudden experience of a solution, that's what we refer to by the term insight in cognitive psychology. So let's look at some examples. Try this out. Without lifting your pencil from the paper, show how you could join all four dots with just two straight lines. So imagine you had to draw two straight lines, and these straight lines are connected, right? So if you follow my my mouse movement here, it would basically be like this: one line, two lines, right? So they're connected one way or another. How can you draw just two connected lines to connect all four dots? Now, try this in your own time. I think what you'll find is, for some of you who get the solution, and I didn't get the solution myself, by the way, you'll find that the result just occurs to you immediately. When you finally get it, you didn't get there by process of elimination and trial and error. It just suddenly occurred to you. That is what we mean by insight. Here, I'm going to give you the solution right now. You ready? Here we go. See? You were fixed in your mental set, your mental model of this problem, where you didn't think about going beyond the dots. Well, most of you at least, myself included. And then once you recognize, oh yeah, I can go beyond the dots, the solution appears immediately. Here is another example which perhaps doesn't get at insight quite as clearly and distinctly as the previous example did, but there's still definitely, the reason why I say that is because there's still some scope for trial and error, but I think this is still an insight problem because trial and error doesn't really help us all that much. So, you can only move one matchstick. Which matchstick do you move to make the two sides of the equation equal? So you obviously have to know Roman numerals to try to get this. Now, again, think about mental models, or mental sets rather, and how with problem solving, we want to try to use a different mental set. We want to try to get out of our traditional mode of thinking about this problem and try to see it in a very different light. So, pause now and think about it. I'm going to proceed with my explanation. The way you are probably thinking about this is not in terms of Roman numerals. You are probably thinking about this in terms of Arabic numbers, you know, the numbers that we see on the keyboard. But if you think about this in terms, you know, that's 4 and that's 3 and that's 3 and so on. If you think about these in terms of Roman numerals and you know, the rules and norms of Roman numerals, you might suddenly see the problem very differently. You might suddenly realize this is a different type of problem to what I was thinking of. This is how I solve the problem. I move that stick over there, so a 4 becomes a 6. It's not like I didn't actually have to do like addition and subtraction or anything. I just had to move a stick around so that that stick means something different, right? So it's a very different solution to the problem than at least I was thinking initially when I first tried this. Here's another example. Now that you have this mental set, try to solve this problem. I'm going to give you the answer now. And finally, let's try this one. Again, pause, take some time. In class, I would be allowing, you know, a good 5 minutes for this set of problems. See how you go with this. I'm going to give you the answer now. So, the reason why I waver on calling this insight versus mental sets, I think it's some sort of hybrid of the two. It meets halfway between the two, is that you can establish, it does require some insight at first. You have to suddenly have this insight of recognition of like, oh, I have to, you know, completely change the way I'm thinking about this. And, well, no, sorry, correction. You are relying on mental sets and changing your mental set to figure out the problem. So there's your kind of step-by-step approach, right? You recognize that the mental set you were relying on was not helpful. You change your mental set to see that you can just move a bar around to change the very meaning of the plus sign to become an equal sign or something like that. Or this equation could be, you know, a 3-piece equation rather than a typical 2-piece equation. So there's the mental set alteration, which will help you help put you in the right direction. So that is kind of a step-by-step problem-solving approach. However, the ultimate solution of changing the plus sign into an equal sign, that's where insight comes in, and you're more likely to get the answer just like out of the blue without any without all that much kind of step-by-step processing leading to that sudden realization. Anyway, as we've seen from that previous example where I kind of wavered and thought, you know, that problem of, you know, the matchsticks problem is not entirely the Gestalt approach. It's not entirely a matter of insight. It seems to be a bit of both. Well, that kind of reveals one of the problems we have when we're researching this phenomenon of insight. How do we know we're actually tapping into insightful processing, you know, like the sudden realization of a problem versus gradual step-by-step realization of a problem's solution? It's very difficult to determine this objectively because we rely on subjective reporting and we rely on these various methodologies which may or may not be good at actually distinguishing insight from different types of problem solving. So how do we overcome this? Well, researchers try to, first of all, we have to actually establish, we have to find evidence to support the theory that insight is actually different psychologically to different types of problem solving, right? So we need to come up with methodology that really highlights the clear distinction between the two and that overcomes the problems that we mentioned before. Now, this example still has some issue of, you know, it's self-reported. Participants are reporting, they're self-reporting their own impressions and feelings and so on. So we still have that problem to some degree. But arguably, that problem is downplayed a little bit. Let's just take a look at the example, right? So participants were given either a problem which the researchers thought was going to be, you know, you can't kind of figure out the answer step by step. It has to be just a sudden light bulb moment. But then they also gave him an algebra problem where you can figure out an algebra problem in a step-by-step format, right? So, you know, if I give you 2a plus b equals 3 or whatever, and then you gradually solve step by step. Well, a therefore equals that, and b equals that, and you put it all together, and in the step-by-step fashion, you solve the problem, right? So that's the algebra problem. The researchers came up with a very different problem for the participants who received this quote-unquote insight problem. So participants would self-report on their feelings of warmth, right? Like getting warmer, getting closer, right? I'm closer to figuring it out. They would give their subjective impression of feelings of I'm getting close to solving the problem. So that's why I wavered just now a little bit, saying that, like, okay, they still haven't completely overcome this issue of self-report, right? We're still relying on self-report. However, one advantage is self-report is now no longer a variable. Both conditions are giving self-reports of their state, right? So that's a constant across both conditions. So if we see differences in responses to the two conditions, well, it can't have anything to do with the instructions about, self-reporting or how close I'm getting to solving the problem, because both conditions have to do that in the same way. So anyway, what were their self-reported warmth ratings? Those in the algebra group, yes, they showed a gradual step-by-step increase in how close they felt they were getting to the problem, right? And then when they finally get the answer, they say, aha, eureka, I got there in the end, and now I'm 7 out of 7 on this scale, and then 15 seconds ago I was 15 out of 7, and so on and so forth, right? What about the other condition? No increase, negligible increase, and then suddenly, bam, got the solution, right? So here we see evidence that different problems, we see evidence that different problems trigger different modes of problem solving, and that we can actually distinguish different types of problem solving. There really does seem to be some problems that are solved with, insight and just immediate intuitive, oh, I got it, I finally see it now, and other problems that require a step-by-step processing, right? And now, the problems that require insight, when participants suddenly see the answer and they suddenly get it, trying to connect the dots here to stuff we talked about earlier in the lecture, the likely theoretical explanation is that they restructured the problem, and then when they restructured the problem to see it in a different light, then they were able to say, aha, now I've figured it out. So why is insight so difficult? Well, we get fixated on one particular way of thinking about the problem, right? So I've discussed this throughout the lecture. And now we're just going to focus on it directly. But throughout the lecture, I've been talking about, how we'll get stuck in one way of thinking about the problem. We'll have one kind of gestalt about the problem, and we need to establish a different gestalt, a different holistic impression of the problem if we're actually going to figure it out. And then once we do establish a different gestalt, and that gestalt turns out to be relevant, well then we might be able to have that sudden spark of insight and be able to solve the problem immediately. So we've been talking about mental sets. Mental set is one way of thinking about a problem. It is a schema for a particular problem with all sorts of assumptions and stereotypes and so on. Now, fixation is an inability to see that same problem from a fresh perspective, right? So this is one of the big problems we see. We want to get away from our fixated mental set and try to explore different mental sets, but it's very difficult to do that because of how we usually think about the problem and how the mental set usually structures our thinking about the problem. So I've given you this example already, right? And so you are fixed by a mental set of thinking that, connect the dot activities, you usually can't go beyond the dots. But it didn't say anything about that here. So once you get over that mental set, then you get this sense of insight. And as I said, you might be able to then apply this new mental set to new problems, right? So here's this new problem, connect all 9 dots with only 4 lines without lifting your pen, and here's the solution, right? So having done the first one, you've established a new mental set, and this mental set does not entail the rule that you can't go beyond the dots. Your original mental set had that because, you know, you're used to playing, you know, noughts and crosses and various games where you can't go beyond the dots and so on. Now you've established a new mental set, you apply it to a new problem, you solve that problem really quickly. Just like the example I gave earlier of, you know, forgive and forget, then you solve that riddle, you establish a mental set, and then you see that new problem to have and to hold, I think it was, something like that. And then you're able to solve it pretty quickly. So functional fixes, so we get fixed into particular mental sets and impressions of a particular problem and how to solve it, right? So this often occurs when we consider the function of the things in our problem-solving scenario, right? So we think of objects and their typical function, and it's very difficult to think beyond that function. Again, let's go back to the example I gave you at the very beginning of the lecture, the brick. Think of various usages of a brick. Well, what is a brick typically used for? To build a wall, or to build a structure, or to prop something open, or to act as a little step, maybe. That's pretty much it. And so you having to come up with alternative functions, uses for this brick is a genuine measure of creativity because it's forcing you to think beyond its typical function. And indeed, this is one of the main problems why problem solving and creativity are difficult, because our minds naturally are going to learn to process and think about a particular object in terms of its typical function. Think about, you know, your day-to-day activity. If you usually think about your car as something that you can stand on top of if you want to paint your house or something like that, right? Well, then you're not going to think about it first when you have to suddenly decide, well, how do I get to my friend's place, right? That might be an extreme example, but I'm sure you can think of various examples in your day-to-day lives where the way you think about a particular object and its typical function affects how likely you are to solve problems with regard to that item, or to use it to solve problems. Anyway, let me give you a clearer example of all of this, right? So let's imagine this scenario. You have these two pieces of cord that are attached to the ceiling. Now, the two pieces of cord are not actually long enough. Correction, they are too far apart for you to actually connect, okay? So the person in this figure, that's basically their arm span. This guy cannot reach that other cord to connect the two cords. If he could reach them, they could tie together, they will connect, but he isn't tall enough to reach. How do we solve this problem and tie the two cords together, even though he can't reach both of them at the same time? Stop and think about it for a second. I'm going to give you the solution now. So look around. You see, it's clear that he's probably trying to paint the room. That seems pretty clear to me, right? He's got this a rag to protect the floor, and he's got brushes and a paint can and so on, right? So our minds are seeing this and thinking, okay, brushes are for painting. Paint cans are for storing paint. But what you need to do in order to engage your creativity is to think beyond the typical function. Don't get fixated or fixed upon the typical function of these items. What else can we use these brushes for? Well, it turns out that you could use a brush as a weight. You could tie the brush to one of the cords and then swing the brush and therefore swing the cord so that when it comes your way, you can reach it. It enters your range of reach and you can grab it. So we solved the problem by looking at this brush and thinking about a function or usage of it very different to its typical function. I gave you this example already. We can, set up the candle arrangement like this. I mean, of course, you might want to actually set the candle inside the box to better catch wax, but whatever. This seems to be the image that is usually presented. Research has shown that if you actually present the box as empty without the matches in it, so you notice over here the box has some matchsticks in it. If you present the box as empty, then it's easier to solve. Why? Because an empty matchbox without any matches in it is less likely to trigger your functional fixedness of a matchbox and matchsticks, right? It's an empty matchbox. Oh, well, I can't actually light a match now. I guess there are other options for using this matchbox, right? And here's a neat example. I'll send you the slides. It's from the movie Mulan. A funny, entertaining, you know what? Oh wait, no, I won't show it now just in case there are, YouTube copyright issues, but you can look at it in your own time. It's a funny example of how to overcome functional fixedness and to establish new usages for various tools and objects. Now, some solutions seem to be useful and unusual. In which case we can say that they show creativity. So if researchers were trying to assess your creativity, how would you use a brick creatively? They might assess simultaneously how unusual and how useful they are. Because, something might be really useful but not unusual. Oh, I'll use a brick to prop a door open. That's useful, but, everybody's going to think of that. Or I might use a brick to I'm struggling to think of an unusual yet useless example, right? I might use a brick to no, I can't even think of one. I guess I'm not very creative, huh? But, I might use a brick and crush it down and add some water and turn it into a paste and use it as makeup. That's unusual, and I think that's very useful and creative, right? Like, imagine if you were, if you really wanted makeup, but you couldn't afford something and you realize, hey, turns out this brick is really useful, right? That would be creative and useful. So we can assess creativity responses like that and kind of rank them, which ones are more versus less creative. Now, we also have this concept of divergent thinking, where there are a large number of potential solutions, right? We have to try to explore those different solutions. Well, this is another facet of creativity and overcoming functional fixedness in our mental sets, right? We have to think of various options and possibilities. Let's have a look at a great example from my wife's world, the world of OBGYN. So some babies are born breech, which means they are feet first or bottom first, which is very dangerous, usually calls for a C-section. And some babies kind of get stuck in various ways, and it's very difficult to get them out, and it might be emergent. You might have to get them out really, really quickly. And a doctor was drinking some wine with some friends, and they had a cork stuck in the bottle, and they thought, oh, this is a fun problem to solve. Let's try to get the cork out of the bottle. And then they used this plastic bag approach. You put the plastic bag in the bottle, it grabs the cork, and then you pull the cork out with the plastic bag. Well, then suddenly the guy had this eureka moment. He was able to recognize the similarities between that situation and the breech baby scenario, and immediately saw, he had this immediate insight, this immediate solution suddenly arose to him because he was able to establish an analogy between the two problems, okay? And it turns out this is now, I mean, not quite with a plastic bag, obviously, but this is the approach that OBGYNs will use sometimes to solve this problem. So this brings us to our final topic, analogical reasoning, and how we can use analogy to solve problems. Here's a funny little example of analogical thinking for you. We often encounter problems that are similar to ones that we've solved before, and I've kind of touched on this throughout the lecture today. So analogical reasoning relies on noticing similarities between the problem we're currently facing and problems that we've faced in the past. Here's an example for you to check out in your own time. And it's very reminiscent of another real world example that I've come across where it turns out that kids who grew up on the streets of Brazil, they might not be very good at, abstract math problems, and they might not be able to, score as high on, SAT or whatever IQ test as kids who didn't grow up in the streets, but they're really good at math when it's presented in terminology that they're familiar with, right? So selling and trading goods and that sort of thing. When you put it in that context, then they're really good at math and they're just as sharp as anybody else. So, often we can't see the nature of the problem because it's presented in a way that we're not familiar with. So here's an example of collapsing stars, right? The literal version, and then here is an analogy version where we think of ice skaters pirouetting and so on. So this is an example of analogical presentation. So with analogical reasoning, we have the target problem. So the target in psychology, you'll hear this term a lot, the target is the thing of focus, the thing that we are directing our attention or a judgment or decision making at. Right, you'll see this in all fields of psychology. So in social psychology, you might refer to, if we're studying prejudice and attitudes, you'll have various different targets of judgment. And one target might be black, one target might be white, one target might be a lawyer, one target might be a nurse, whatever, right? That's what we mean by target more generally in psychology. So the target problem is the problem in front of us that we're trying to solve. The source problem is the problem that acts as a source for us figuring out problem solving, right? That's why it's called the source problem. And then we have analogical transfer. Well, we have to transfer the strategy from one problem to the other. So basically, these are just fancy terms for a really simple process, right? There's a problem we're trying to solve. There are other problems we've solved before, and then we can see if we want to transfer problem solving strategies from one to the other. Now, here's a really neat example. Have a read of that in your own time. See if you can, just spend 20 seconds, see if you can solve the problem. Most likely you won't be able to because it's quite difficult. Now, I'm going to show you the next example in your own time. Pause, proceed as you like, and read this next example. Now, when you've read that, think about how this might help you solve the problem, the first problem, right? Try to draw parallels. Try to establish analogies, right? And use that analogy to see if problem solving for one problem can be transferred to problem solving for the other problem. So as we can see here, there is an application of the problem solving approach in one to the other problem. So we can apply that, and sure enough, when participants aren't given the analogy, they do poorly, 10%, thereabouts get it right. When they do get the analogy, that jumps up to about 37%, but notice that we're still not very good at reasoning, right? People need that extra hint in order for most people to get it. So even though analogical reasoning is really valuable and useful, it doesn't necessarily come naturally to us, right? So many of you would have maybe have seen those two scenarios that I just presented, and you still didn't quite see the connection between the two. And that's not because you're dumb or anything like that, right? This is difficult, and it requires a lot of attention, and did you skip breakfast this morning or whatever? This stuff doesn't come naturally to us, and so having these cues and directions can be really helpful. So with analogical reasoning, we've got these three essentials, and I'll let you read these in your own time because it's pretty self-explanatory. And here is the summary of what we have covered today. Now, I sent you out a little example of problem solving. Normally, that would have been the first part of our lecture, and I'd come back to it later when I could analyze the results. Send me your responses as soon as possible, and then I'll try to analyze the results, and you'll see what I'm getting at with that. Normally, as I said, we would have a lot of time during class for actually trying to solve these various problems that we've come across in this lecture. So if you did skip over some of them, try to go back and think about it, try to solve some of the problems, and just observe your own problem solving strategies. Beyond this, I'll get your homework back to you as soon as possible. As always, contact me or better yet, post on the discussion forum on Canvas if you have any questions.